Okay, in this next lesson, we're going to talk about integer exponents. Now, some of you might have covered these a lot in grade 9. Some of you never have, have rarely encountered them. You must have come across them here or there a little bit. But negative exponents, basically, that's what we're really talking about when we say integers. We really want to talk about what do we do with negative exponents. We know how to handle positive ones. That's that whole previous lesson. The negative exponent generally means the result should be the reciprocal. Right? Notice how I have x to the negative m. Now it's 1 over x to the m. So it becomes a reciprocal. So why does it do that? Let's talk about this. Reciprocal. There we go. Spelling. Okay. So let's look at this the expanded way to make better sense of it. So what do we have on top here? I have 3 x's, right? 1, 2, 3, all multiplying. And on the bottom I have 7. 1, 2, 3, 4, 5, 6, 7. Running out of room there. Okay, so obviously each x term is the same as the x term on the bottom, so I can divide them now without worrying. Get 1. X divided by x is 1. X divided by x is 1. All right, so those all cancel out and make 1. What are we left on top with? A 1. What are we left on the bottom with? 4 x's, right? X to the 4. Okay, so there you do it that way. I think it makes pretty easy sense what's going on there. Let's compare it now using the exponent law. The exponent law, we would take these x's, and since it's quotient, right, we're dividing, we're going to subtract them. So we're going to go 3 minus 7 gives me x to the negative 4. Now, we've run into this situation before. How can we have two different solutions, right? How can we get this over here and this over here, right? These two things have to be the same, right? You can't have two completely different solutions for the same question. All right, so that's basically not a proof, but trying to visualize and understand why this becomes this, okay? So generally, once we have a negative, it basically means that this term, this base, is sort of in the wrong spot. It either needs to be flipped to the denominator, or if it's on the denominator, it has to be flipped to the numerator. So this, we generally rewrite like that. So for example, like if I have, let's just go a to the negative 2, I would write that as 1 over a to the 2. Or let's do b. If I have 1 over b to the negative 3, that basically means it's supposed to be up here. It should just be b to the 3. So we basically take the reciprocal, we switch it from numerator to denominator or denominator to the numerator, and we remove the negative. So really anything, if someone gave you 2, you could write it, no one would really do it, but you could write it like this, 2 to the negative 1. Those are the same things. Because if I flip this back up and then switch it to a positive, I just get 2 to the 1. Okay, so let's go through some examples here and try to break this down. So before we go any further, let's just kind of explore the relationship between positive and negative exponents. I think we're pretty comfortable. We've talked about anything to the power of 0 is 1. We covered in our last lesson. If you don't remember why, go back and watch that, right? So there's sort of in the middle of this, right? 2 to the power of 0 is 1, right? 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 16. Notice how each time we are doubling, right? We're just doubling, right? It's getting bigger. Well, look what happens as we go down, right? 2 to the negative 1, that's 1 over 2 to the 1, right? Or 2 to the negative 2, that's 1 over 2 to the 2, which is 1 over 2 times 1 over 2. 2 to the negative 3, 1 over 2 times 1 over 2 times 1 over 2, and so on and so forth. Notice how they're getting smaller. But if we look at it, just depending on the way we look at it, if I double this, double this, double this, right? The pattern continues. It never stops. There's no break in this pattern. So the pattern is standard. It follows the same pattern the whole time. It's consistent. It's a constant pattern of multiplying by 2. And same thing, if I reverse this and go down, right, all we're doing is dividing by 2, right? Divide by 2 and so on and so forth, right? Divide by 2, divide by 2. 2 divided by 2 is 1. 1 divided by 2 is a half. So as we go into negatives, right, see, the pattern continues, okay? And half of that is a quarter, and half of that is an eighth. Okay, and the pattern continues. So just getting the idea of that this pattern, it doesn't get weird or different when you get into the negatives. When you look here, it might seem like it, but it's really the same pattern of either increasing or decreasing, which way you like to look at it, right? Whether it's exponential growth, when we increase, we call it, or when we're shrinking, going into exponential decay, right? Depends on which way our numbers are moving when we get into some of these exponential problems, as you'll see. All right, so let's go through some just basic algebra with this stuff and make sure we're ready to rock. All right, so let's just look at a few basics here. Example 1, I just got 4 questions here. Again, if I have 5 to the negative 2, that's the same thing as saying 1 over 5 to the positive 2, which would be 1 over 25. We want to try and avoid decimals here. If you go put that in your calculator, it's going to give you the decimal equivalent of that. So let's just pop up a calculator here and see. If I go 5 to the power of 2 negative, right, I get 0.04, which is what 1 over 125 is, right? So obviously you can punch this stuff in your calculator, but those of you who want to continue in math have to make sure you keep working on these skills without relying on your calculator for everything. Now, same problem we were talking about earlier. I got the negative exponent on the bottom. That basically means that this should be moved to the top, okay? So what it really should be is 2 to the power of 3. So it's just 8, okay? Now again, you want to prove that in your calculator, double check it. Let's bring that calculator back up again. Let's clear it out and do the exact same thing. Let's go, what's 1 divided by 2 to the power of 3 and put a negative in front of it? 8. There you go. So there's some proof, okay? Now there's a couple different ways we can look at it. When I generally look at this, I go, all right, 1 over 4, I can't do much with that other than make it a decimal. I got a negative here. What I could look at this is I could look at like this, 1 to the negative 3 over 4 to the negative 3, and then switch them, right? Or what I generally do is I go, well, it's negative. Why don't I just flip them both? Why don't I just make this 4 over 1 now to the 3? And 4 over 1, that's just 4. So this is just 4 to the power of 3. 4 times 4 is 16, times 4 is 64. There you go. Here's where people get into trouble. A lot of us go, oh, cool. I'm just going to do what you did in the last question. I see a negative, I'm going to flip everything. I think we're forgetting bed mass, right? We have to do what's in the brackets first, okay? So if we want to get the right answer here, we have to follow bed mass because there's a subtraction here. And that takes higher order of precedence because it's inside the brackets than the exponent on the outside. So we shouldn't be dealing with this yet. If we are, we're going to make some mistakes, right? All the other ones had only one term in the bracket if there was a bracket, right? So in this case, what we're really going to do is go, okay, well, what's 3 to the power of 0? 3 to the power of 0 is 1 minus, what's 3 to the negative 1? Well, that's 1 over 3. I have to complete what's in this bracket first. So I'm going to get a common denominator, 3 over 3 minus 1 over 3. Now I've got it down to 2 over 3 to the negative 2. Now it looks more like this one. I've completed the operations inside the bracket, right? Now I can go outside and say, what's next? Now I can go, okay, there's a negative there. So I'm just going to flip this and make it 3 over 2 instead of 2 over 3. And I can square them both. 3 times 3 is 9. 2 times 2 is 4. So there's your simplified answer without having to completely rely on my calculator, right? All right, let's look at a few more examples here. Okay, in example 2, we're just going to go a little bit further and just do a little more basic algebra or a little basic number work here. Now, you have two choices here. You could do it this way. You could go, all right, well, 4 to the negative 3, that's 1 over 4 to the 3. And then, times 4 squared, that's 16, and this is 1 over 4. But they all have the same base. So I'm going to try and take the shortest path I can. They all have the same base, and we're multiplying. So you know what I'm going to do is I'm going to add the exponents. Remember our product rule? Negative 3 plus 2 plus negative 1. So I'm going to end up with 4 to the negative 2, right? All right, now that I've got it down to just one term again, basically what I'm trying to get at is not always, but a lot of times you kind of wait till the end to deal with that negative exponent. You kind of exhaust your other options first, right? I use the product rule to simplify things as much as I can. Now it's just 1 over 4 to the 2, which is 1 over 16. There you go. Now this one, same base, right? The base is negative 2 in the brackets. So why don't we leave that negative 2, same base alone, and we're dividing. So what can we do with we're dividing? Subtract the exponents. So I have negative 4 minus negative 1. So now I have negative 2 to the negative 4 minus negative 1 is negative 4 plus 1, negative 3. Now that I've got it down to one term with that negative exponent on, because sometimes you do these operations here or you do these operations here and you don't end up with a negative exponent at all in the end. So you know what? Now we get it down here and now we do have a negative exponent. We're stuck. So let's just finish it. So this is 1 over negative 2 to the 3. Here's the big mistake also people make here. I should mention it, right? A lot of people go, oh, 2 negatives, that equals a positive, right? Nope. Right? This negative here is just telling us that we need to take the reciprocal to flip this. All right, so now I have 1 over negative 2 to the 3. Well, negative 2 times negative 2 times negative 2 is negative 8. Let's put the negative out front. Again, we don't want to leave negatives on the bottom of our fractions, okay? All right, final one here. Again, instead of flipping, some people start flipping and flipping. No. Let's use our exponent laws first. So we did the product rule, we did the quotient rule. Now we have the power of a power rule. Remember in this case how we can multiply the exponents? So when you have a power of a power, this is 3 to the negative 1 times negative 2. That's going to give me 3 to the 2. Oh, cool. The negatives disappeared. I don't have to deal with them, which is 9. Now, these are simple questions, but I'm trying to get at the heart of the problem. Even when you're doing bigger ones, the idea is maybe use your exponent laws first. Don't start changing the base. Don't start flipping things. Use your exponent laws to simplify the exponents as much as possible. Then, when you've done that, like when I get to negative 2 here, I get to negative 3, or I get to positive 2, then I'll decide what to do next. So simplify using your exponent laws first. Let's look at a couple more quick examples here. Well, to be honest, after the last ones, these ones are pretty easy. These are all algebra. We can't do anything with the bases, but notice how these all have the same base. They're all x. So what can I do? I'm multiplying so I can add the exponents. Add, right? So I'll write it out here. I have negative 2 plus 5 plus 0. Don't go, oh, it's the power of 0, so everything's 1. No, not everything is 1. You're basically saying, let's add the exponents up. Negative 2 plus 5 plus 0 is 3. Done. Notice how I didn't get into flipping stuff right away, making it more complex on myself. The moral here is, or the lesson I should say, not moral, is to use your exponent laws first, okay, to simplify things. And you can usually whip through these questions a lot quicker. Now, where you can, exponent laws first, when possible, because we're going to see in a minute they are not always possible, okay? Next one is pretty easy, right? Same thing. We're dividing, so what can I do with the 3 and the negative 5? I can subtract them. If you have two negatives side by side, you have to put brackets around it, okay? So it's really just 3 plus 5. It's 8. Done. I didn't get into flipping. Notice how I didn't start flipping this negative 5 yet or doing anything crazy, right? I just used my exponent laws. Same with this guy. All right, so it's 2 and negative 3. What can I do with these? Let's multiply. So it's just 2 times negative 3. So we get x to the negative 6. Okay, if you get to your final answer and you have a negative exponent, this is one of those things, it goes teacher by teacher, textbook by textbook. Some scenarios, we just leave it like this and we say, that's good enough. What we want to aim for this year, though, is I need you to get in the habit of rewriting everything with a positive exponent in your final answer. So we really want to write this as 1 over x to the 6 in our final answer, okay? So this is this is our goal. Let's aim for this, okay? All right, moving on to the final examples here. Here we go. Now, this is where things fall apart. I got A, I got B, I have to do some substitution. Let's talk about all the little pitfalls that I've been, trying to impress upon everyone, every student I've ever had, and what my teachers used to impress upon me, and maybe I didn't follow the rules as much as I should have, and it would have made things easier. Whenever we are substituting, we need brackets. Bracket, bracket to the negative 2. Notice that negative 2 is on the outside of the bracket, right? Minus B. Well, what is B here? Let's get a different color. There we go. I'm going to use orange. Bracket, bracket to the negative 1 on the outside of the bracket. The only thing that you should be substituting in is the value that you're replacing the variable with. Now, this should be something you all have 100% locked down at this point if you've made it to grade 11. This is 100% expected if you want to receive marks for your work. No brackets, no credit. So if you write this like this, that's not the same thing, right? These are not the same now, okay? Because like we talked about earlier, remember, with the brackets around the negative can have an effect, right? And whether the exponent's even or odd or not. If you don't put those brackets, you have changed the question. So I know a lot of you don't see it that way yet. A lot of you, I shouldn't say you in personal, but over the years of teaching students, it seems to be a fact that a lot of students don't seem to make any difference of it, heads or tails. But your solution is you've changed the question without those brackets. Okay, you've changed the value of it. And then even if you get the right answer, you've made probably 2 mistakes then, because now you've written it wrong, and then you haven't applied the rules properly to get to that final answer, okay? So in this case, so that's the first thing, brackets. Second case, we are subtracting. There's no exponent law for subtraction, right? So in this case, I just have to evaluate these. I can't put these two together. Look, they don't even have the same base. Negative 2 and 3, they're not the same. So in this case, I'm stuck. I can't really use any exponent laws. Let's just simplify it. So this guy here, well, this is now 1 over negative 2 squared, right? I got rid of the negative and I flipped it. So notice how the only thing changed, I flipped it and did that. Same with this guy. This is now 1 over 3 to the 1. Okay, I got rid of the negative and I flipped it. So 1 over negative 2 squared. Negative 2 times negative 2 is positive 4. 3 to the 1 is just obviously 1 over 3. And there you go. So we're just getting common denominator here. So I got 3 over 12 minus 4 over 12. And we end up getting negative 1/12. Okay. Let's do one more. Again, there is no exponent law for addition. So you can't just start adding these. Even if this was, I know this is an A and this is a B, but even if these were both A's or both B's, you can't do anything here, okay? Sorry, I feel like I'm yelling at you. I record so many of these every day, I'm starting to lose my mind, I think. All right, so here we go. The A, right? There's the A, brackets, okay? There's the B. What are we going to put? Brackets. This -1 here, outside the bracket. This -2, outside the bracket. They do not go inside the bracket. The only thing that goes inside is, like we said before, we're replacing A with -2, replacing B with 3. All right, now, decision time. Again, what is your basic order of operations? Exponents before multiplication. So we have to deal with this first, right? And same with that first. Okay, so this is going to become 3 times 1 over -2 to the 1. Now I'm going to really write this in baby steps just to be really careful here with everything. And 2 times 1 over 3 to the 2. So I flipped them and got rid of these negatives that I'm circling. So let's clean this up. What is 1 over -2 to the 1? That's just -1/2. Right? And what is 1 over 3 squared? That's just 1 over 9. All right, so we can simplify each of these. Now this is 3/2 plus 2/9. And once again, we just need a common denominator. Okay, so let's make it 18. 9 times 3, what do we got? -27 over 18 and 4 over 18. And -27 plus 4 is -23 over 18. And there we go. So again, I didn't use any exponent laws to add exponents here or subtract exponents. That only works when we are multiplying, dividing, or have a power of a power. So the way I did this lesson, it makes you think that you can use these for all your homework questions. That's not the case. You still have to rely on your order of operations, your BEDMAS. I'm just focusing on the key things that need to be reviewed. You still need all your other math skills and knowledge, okay? All right, thanks a lot, and keep working hard. Thank you.